Apply the distributive property. So the distributive property, which is obviously the key thing that we're doing in this section, can be used to find the product of a number and a sum or difference So a couple different ways that you could see this written out. If we had A times B plus C, then when we distribute, we multiply this piece times each of these things in here, and so we would get A times B plus A times C. Now you may also see it written this way, B plus C and then times A. Even though it's in a different order, we still do the same thing. We're still multiplying it by each thing that's in here. So this would just be B times A plus C times A. And at the end of the day, it doesn't matter which order you write these letters in, because the commutative property that we had allows us to write them in any order and it means the same thing. But that's for addition. We'd have the same thing for subtraction. So if I had A times B minus C, that would be A times B minus A times C. If I had B minus C times A, that would just be B times A minus C times A. If you forget the, what to do with the distributive property, the phrase that my teacher always said, and when I had her, she would always be like, when you get to high school, they're not going to like you to say this, but I still think about it when I do it. But it was be the rainbow. Because when you make these little lines connecting A times B plus A times C, it's like multiple lines and they kind of look like little rainbows. So if you have trouble remembering what to do, maybe that will help you as well. A few definitions that kind of go in this section. Terms, we use that to explain the parts of an expression that are added together. A coefficient is the number part of a term with a variable a constant term is a number without a variable. And then like terms are terms that have the same variable parts. Now with that, you can also have like terms that don't have variables at all. Like if we had two constant terms, those would be like terms as well. So they just technically have no variable. So let me see if I can give an example of this. So if I have 3x minus x plus 2, something like that. Each of these pieces are terms individually. Let me actually do it this way. This piece, and this piece, they're all terms. These right here specifically are like terms. They both have a variable of x, so we can combine those. The numbers in front of the variables are coefficients. And then the number by itself is a constant term. So when we're adding, subtracting, things have to be like terms for us to combine them. Otherwise, they just have to stay separate. So using the distributive property for some examples here. Let's use the distributive property to write an equivalent expression. So if I have something like number 6, 8 times y plus 2. I multiply 8 times y and 8 times 2. So that gives me 8y plus 8 times 2 is 16. So it would be 8y plus 16 would be our answer. Number 8, n plus 6 is in parentheses, and then it's being multiplied by 3. So I'm basically kind of like working backwards. Anytime you're writing a number and a variable together, the number should always come first, and then the variables, if there's multiple, should be written in alphabetical order. So it should be, like with this one, 3 times n plus 3 times 6 is 18, so it would be 3n plus 18. Yes?
So when we're doing the homework, do you want us to draw those lines connecting them?
You don't have to do that.
Yes.
But you do need to write the original problem and then write the answer like this. I don't usually draw the lines for myself. I'm just doing that for a visual for y'all. 10. -4 times q minus 4. What would I get with this one?
-4q minus -16.
No, plus -16.
So what's negative times negative?
Positive.
Positive, so it's going to be positive 16. So we got to really make sure we pay attention to signs on these ones so you don't miss something like really small like that.
So you always want to put the one that has the variable first and then put the other one?
I mean, that's the preferred method because ultimately that's what you're going to find out is called standard form, but that's like way later on where we like talk about that, where like the higher powered terms like come first and you work your way down. But what I'm more so saying is like if you multiply like a number times a variable, you always write the number first. Like don't write it like this. Like write it as 4q when you multiply it.
Okay.
Like that. Because if you write it this way, you can also get confused when there's like a negative because you may say, well, it's negative or it's like q minus 4 when you really mean it's negative 4 times q. And so it can get confusing. So that's why we do the variables after.
Got it.
14. Negative w times 2w plus 7. What do I do with this one?
U times the 2w times the negative w.
And what do you get when you do that?
Double w.
Negative 2w squared.
Double W. That was cute. So anytime we multiply a variable times itself, will become squared. So it will be negative 2w squared. And then what do I get when I do negative w times 7?
Negative 7w.
Yep. Let's see, 18. Negative 3 over 4 times p minus 1. So still, even though there's a fraction, I'm still multiplying it the same way. So what do I get when I do this one?
Negative 3/4 p and 0.5. I mean 0.75.
Plus 3 over 4. If it starts it as a fraction, you need to leave it as a fraction.
Same thing.
All right, identify the terms, like terms, coefficients, and constant terms of the expression. So the way that I labeled this one up here is essentially what we're doing. So let's see. (24) Negative 3y squared plus 3y squared minus 7 plus 9. So what are the terms?
Negative 3y squared, 7 and 9.
Yep, so each of these pieces are the terms as a whole. What are the like terms?
Negative 3y squared and 3y squared.
So these are like terms. Are there any other like terms? Yep, the two constant terms are also like terms. What are the coefficients?
The numbers, the symbols or numbers before it, the like terms? Or no,
3y squared.
Yeah, specifically before the variable. So the negative 3 and the positive 3 are the coefficients. And then what about constant terms?
7 and 9.
Yep, 7, negative 7 and 9 are the constant terms. So that's all you have to do on problems like that.
When we're writing it, is it okay if we like break it down a little bit more? 'Cause it's like
kind of hard for me to write it without the lines.
Yeah, no, that's fine. Yeah, I would probably, well, yeah, that's fine. However you want to break it down. As long as I can tell what you're trying to say, then that's fine. All right, simplifying the expression. $30. 5 plus 2n plus 2. So basically, when they say simplify the expression, they mean combine like terms. So, what would this one become?
2n plus 7.
2n plus 7. Y'all leave it and put it in my favorite order. 32. 3 times 2 minus c minus c. What do I have to do first?
Combine your like terms.
Can't do that yet.
Parentheses. Wait, you can do that.
What's this whole section about?
You apply the 3 to the 2 and the c.
Yes, distributive property. So what do I get when I do that?
6 minus 3c.
Yep, and then don't want to forget this one over here, minus c. Now what do I do?
Like terms.
Combine like terms, and what does that give me?
6 minus 2c. What?
Negative 3c minus c is?
3 negative 4c.
Yep, negative 4c. So remember, if they have the same sign, we add them and then keep the sign of whatever it was. So 6 minus 4c. And this is how you should be showing your work, okay? Other than you don't have to draw the little lines, but you should show the distributive property happening first, and then you're combining your like terms, okay? Yes. 34. 15t minus t minus 4.
And there's some distributing.
Do what?
Distributing.
What am I distributing?
15t, t and 4.
Nope. What sign is this?
Negative. No, subtract.
Okay, it's a minus sign, right? So this isn't touching this, so I can't distribute this to everything. But I am distributing this imaginary negative 1, right? So that's going to both of those things. So I bring down the 15t. Now when I distribute this negative, what does that give me?
Negative t and positive 4.
Yep, negative t and positive 4. Now I combine my like terms, and what do I get?
16t? No, 14t.
14t plus 1.
Yep. Are we okay on that kind? All right. The last thing is finding perimeter and area of a rectangle. I want to refresh our memory. What is the perimeter of a rectangle?
Length
times
times
width.
width.
Wait, perimeter?
No,
Length times 2
Two
plus
times
width times 2.
2L plus 2W. So that's the perimeter of a rectangle. What is the area of a rectangle?
Length times width.
Yep, length times width. So these next couple problems give us a rectangle, so number 40. We have a rectangle. The width is 5. The length is v plus 3. And they want me to find the perimeter and area of that rectangle. So to do the perimeter, that's going to be equal to 2 times v plus 3 plus 2 times, the width is 5, so 2 times 5. So how do I go about solving this?
So it's gonna be 2v plus 6 plus 10.
Yep. And then what does that give me?
2v plus 16.
2v plus 16 is my perimeter. So that's the first part. Then they want me to find area. So when I do area, it's going to be length times width. So v plus 3 times 5. And what do I get when I do that?
5v plus 15.
5v plus 15. Any questions about that? So it's just an application of this section, basically. Alrighty. That's it for that section. So I'm going to explain to you, well, I'm going to give you your problems, and then I'm going to explain what's going on for tomorrow. 5, 9, 15, 17, 23, 31, 35, 39, and 41.
Isn't volleyball leaving early?
Yeah, that's what I was getting ready to explain. So volleyball leaves early, but we leave at 2:15, so you're only missing like 12 minutes of class, so you'll be in class most of the time. Cross country leaves at 12:45. So if you are on cross country, you need to come see me tomorrow to get the worksheet that I'm giving them tomorrow. Okay? I might be able to have it copied by the end of the day if you want to come back and get it, but I don't have it copied yet because I wasn't sure if we were going to get through this. So tomorrow in class, you're going to have time to work on this. So it's Wednesday. You don't need to do this tonight. Okay? This is what you'll do tomorrow in class. You'll turn this in, and then I'm also going to give you one of those punchline worksheets. That's a distributive property worksheet. Okay? So those will be what the 2 things you're doing in class tomorrow. So if you're out with cross country, you need to have that done and turned in on Friday. If you're leaving early with volleyball, you may get it done beforehand, but if not, you need to take it and finish it and turn it in on Friday. So there'll be a sub in here for the last like 15 minutes for those of you that are left. But anyways. All right.